Hey folks! Well, now that we've gone through the process of taking our source code and looking how to use a scanner to tokenize it, now we want to take that stream of tokens and parse it and try and find out what the structure of that sequence of tokens actually means. So is it an if statement? Is it a while loop? Is it a whatever? What kind of structure does it represent? And is it a valid structure under our language? So what we'll try and do is have our parser produce some kind of a structure that represents the syntactic meaning of the program. So it will be either something like a derivation sequence or a parse tree, something that represents the structure that we can derive from the grammar rules for the language and from the stream of tokens. So usually I'm going to describe these things in terms of a parse tree, and we'll talk about parsers as either top-down or bottom-up, based on whether they try and build this tree-like structure starting from the top of the tree and work down, or starting from the root non-terminal for the grammar down towards the tokens, or from the tokens up towards the root non-terminal. So thinking about it in those terms, if we've got, earlier we looked at the idea of formal descriptions of languages using regular expressions for our tokens and using context-free grammars for the syntactic rules for the language. If we're working from that kind of assumption, then we've got a sequence of grammar rules that describe, for any non-terminal, how can we replace it with a sequence of other tokens and non-terminals. Right? We've got some start symbol that represents the top abstract level of a program in our language. Then for any given string, if we're trying to see what that means under the language, or if it's even valid under the language, we're trying to produce some derivation sequence, some sequence of the rules that we can apply to the non-terminals to eventually arrive at that string. So for instance, in this particular string, if we've got S can go to an A followed by B, B can be the symbol B followed by more of our non-terminal B's, or it can be symbol C. So essentially this is talking about a language where we start with an A, we have one or more B's, and then, or pardon me, we've got an A and then 0 or more B's followed by a C. So if we were trying to derive this particular sequence, then a derivation that does it is to apply that first rule to get the A at the beginning and then our non-terminal B, and then replace that B with a B and a non-terminal B, and then replace that B with a B and a non-terminal B, and then replace that final B with a C using the third rule. Right? So we can either provide a description of how to get there as a sequence of which rules we apply to which symbols, to which non-terminals, or we can represent it in a tree-like structure where we say, okay, well, I'm starting with that start symbol, I'm replacing it with an A and a B non-terminal, I'm replacing that with a B and a B non-terminal, I'm replacing that with a B and a B non-terminal, and I'm replacing that with a C. Right? So you can get either a tree-like structure or a derivation sequence. So again, when we're talking about top-down versus bottom-up, we're just talking about whether we're going to work from those non-terminals or from those terminals at the bottom of a tree and try and find rules that we can apply to group them together and work upwards towards that root, or whether we're talking about a top-down approach where we start at the root and see if there's a rule that we can apply to get a new set of subtrees, and if somewhere within that there's another rule that we can apply to develop our subtrees, until eventually the leaves form the terminals that we're interested in, the tokens that we're interested in. So top-down versus bottom-up approaches. And again, we're visualizing the results as this parse tree, where the leaves are the tokens, the terminals in our language, and the internal nodes are the non-terminals that we can expand with one of our grammar rules. And again, I believe this is pretty much saying what we discussed. Our top-down parsers start from the top non-terminal and repeatedly try and pick which non-terminal we can expand next and which rule to apply to it, until eventually we have the tree fully evolved and we have a collection of tokens in the leaves of the tree that match the input sequence. If we mess up, if we make an incorrect choice of rule to substitute for a non-terminal somewhere within the tree, then when we get to the leaves, we won't be able to find a way to get them to match with our input sequence. So depending on the nature of the parser, it might back up and say, okay, well, that derivation didn't work. So if we were trying out our tree here, if we tried a different rule for this non-terminal and had a different structure, then eventually we get down here somewhere and find out that we can't make this work, and we back up and try and pick a different derivation rule to apply to this non-terminal and work forward from that. So you're backing up and trying again and backing up and trying again until eventually you either run out of options or you find a derivation sequence that works. So we'll look at top-down parsers and see how we can make that work. And then the flip side are the bottom-up parsers, where again we'll start from the leaves of the tree and we'll try and work up. So what will happen in a case like this is we'll start reading through our input sequence. So let's say we've got, it's working from a different grammar here, let's say we've got this sequence that we're trying to analyze, A, B, C, D, E, F, G. And we're reading through this, and maybe we've got a rule somewhere in there that says the non-terminal X can go to a B, C, D. So as we're reading through this, we see this sequence B, C, D and go, oh, wait a minute, that could come from an X. And so we try that out. We try and build the tree and replace that B, C, D with an X. And so now we've got an A, an X non-terminal, and our E, F, G. So now we try again, see if I've got an A, X, E, F, G, is that, or is a portion of that the right-hand side of some other derivation rule? And if so, can we build that as the next step going up the tree? And so we're trying to group our terminals and non-terminals together and build rules working our way gradually up the tree to see if we can arrive at the root, right? To see if we can use up all of our terminals and eventually wind up at the root of our tree. So, completely different approaches, and we'll take a look at different ways to implement each of them. So, that'll be the plan for the next couple of weeks.